Example 2 in 8.3 in Math 30-1 kind of, I think, showcases the point of these log laws, is that it does allow us to evaluate logarithm expressions a little bit easier. Just a quick example, I don't know what log base 6 of 8 is, and I would argue that nobody really knows perfectly without the use of a calculator. So in order to deal with that, we are just going to work left to right using our log laws. So it's log base 6 of 8 plus log base 6 of 9 minus log base 6 of 2. I'm going to deal with these first two logarithms first. Because there is addition, I can write that as the multiplication of their arguments. Now, what I'm doing here is I'm using my addition log law, or my product log law, in reverse. So I'm going to write it out that the log of n plus the log of m is equal to the log of n times m. That is presented to you on your formula sheet kind of from right to left, but it's just as true from left to right. And that's something pretty typical in math classes that will teach you a theory, and then we'll talk about how you can do it in the other direction as well. Well, we're not done yet. It definitely, getting this into a single logarithm is a lot simpler. So I'm going to write this as log base 6 of 8 times 9 divided by 2. Well, 8 times 9 is 72. 72 divided by 2 is 36. So this is log base 6 of 36. Now, talking through what log base 6 of 36 really is, log base 6 of the argument 36 is equal to whatever exponent I would have to put on 6 to get the value 36. Now that, this is the problem with trying to, speak math. It's very difficult. It's very confusing. If I identified log base 6 of 36 as equal to a value, and let's just say t arbitrarily, when I switch that to exponential form, I get 6 to the power of t is equal to 36. Well, I can write that as 6 to the power of t is equal to 6 squared, and t, the value of the logarithm, would have to be equal to 2. Now, the bottom line is you have to get comfortable with logarithms that when you see log base 6 of 36, you know to write that as 2. Now, as always, I like to present an option in case you're struggling with this, doing it mentally or, without a calculator. Log base 6 of 36, I can use my change of base formula and write it as log base 10 of 36 divided by log base 10 of 6, and you will definitely get 2 doing that. Okay, I'm just going to move these other two to a new page. I kind of used more space than I thought I would. And we're basically just going to keep using our log laws to try to simplify this as much as possible. Now, when I run into a question with a radical, so that's log base 7, I'll put the bracket on there that it's 7 times the square root of 7. The first thing that you should do, and this is something that I push in my math classes, is radicals are great. Square roots, cube roots, fourth roots, fifth roots, and so on. They're useful. They're a nice visual way of, perceiving what we're doing. But mathematically, radicals should really be presented as fractional exponents. It's just a better technique in the long run. So this can be written as log base 7 of 7 to the power of 1 times 7 to the power of 1/2. Now, I know I didn't really need to write 7 as 7 to the power of 1, but I wanted to do that because the next technique, you could certainly combine these, 7 to the power of 1 times 7 to the power of 1/2 is 7 to the power of 1.5. And if I take log base 7 of 7 to the power of 1.5, this is just equal to 1.5. And that's great. We should be able to do that. But I actually like using my log laws in this a little bit better. This becomes log base 7 of 7 plus log base 7 of 7 to the power of 1/2. Well, the exponent I put on 7 to get 7 is 1, and the exponent I put on 7 to get 7 to the power of 1/2 is 1/2. 1 plus 1/2, I'll write it. It's 2 over 2 plus 1 over 2, which is 3 over 2, or 1.5. And we get that same number using a couple different techniques, which I think is important to see that there is usually more than one way to manipulate a question. All right, just to be consistent, I'm going to rewrite b before I solve it. So we have 2 times log base 2 of 12 minus, in a bracket, log base 2 of 6 plus 1/3 times log base 2 of 27. What I'm going to do, and this is pretty typical in math, is we are going to deal with the bracket first. So I am going to make sure that I deal with that inner expression before I touch anything else. So within that bracket, there is addition. In order to deal with that addition, we have to do something first. And if you do have your formula sheet, take a look at the log law for the product law and the quotient law. The logarithms don't have any coefficients. We have to make sure we get to that point. So I'm going to do it twice here. I'm going to turn this coefficient 2, I meant to underline it there, this coefficient 2 into an exponent. So this is going to be log base 2 of 12 squared minus, in a bracket, we'll have log base 2 of 6 plus log base 2 of 27 to the power of 1/3. All right, now that the logarithms inside the bracket do not have a coefficient, I can combine them using my product log law. So I'm going to be subtracting log base 2 of 6 plus log base 2 of 27 to the power of 1/3 is log base 2 of 6 times 27 to the power of 1/3. And I'll put a bracket around the argument. Now we have a logarithm subtracted by another logarithm, so we can combine that into log base 2 of 12 squared divided by 6 times 27 to the power of 1/3. I'm going to write this work over here that 12 squared is 144. And this one I'll write kind of twice here, that 27 to the 1/3 is the cube root of 27, which we should know is 3. Now what that allows me to do is simplify my logarithm. So instead of the log of this relatively complex argument, I'm going to write this and simplify it into log base 2 of 144 divided by 6 times 3, which is to say log base 2 of 144 divided by 18, which is log base 2, and I need my calculator for that to make sure I don't mess it up. If we do take 144 divided by 18, we get the nice number 8. And the last thing I'm going to do here is one last time. If I have log base 2 of 8, I'm going to make that equal to, I don't know, let's say n. And when I switch to exponential form, I get 2 to the power of n is equal to 8. Well, that means 2 to the power of n is 2 cubed. So the value of the logarithm is 3. Now that means that that ugly expression in C there is just the whole number 3. That is the value of that logarithm. Now, it is technically possible to type that ugliness in and get 3, but we want to make sure the point of this is not evaluating logarithms. We have computers. We got that handled. What we need is you to develop the mastery of using the log laws so you can manipulate exponential and logarithm equations to solve them, and really just get used to how we use the logarithm, because it is very, very useful.